We're going to go ahead and talk about a geometric sequence. Remember, sequences are when you are just listing terms like what we have at the bottom. This is an example of a geometric sequence. For geometric sequences, you're multiplying by the same number each time. Remember, with arithmetic, you are adding the same number each time. So here we're multiplying by the same number each time. We're multiplying by 3. 5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135, and so on and so on. That number that you're multiplying by each time is referred to as a common ratio. We end up getting a geometric sequence when we multiply by that common ratio each and every time. Now, just like there is a formula for arithmetic, there's a formula for geometric sequences. A sub 1 is still the first term. A sub n is kind of what you're looking for. R is your ratio, that thing that you're multiplying by each time, and n is your position. Now, if you're given a geometric sequence, or what you think might be a geometric sequence, you need to find R. R is that common ratio. Sometimes it's easy to see. Most of you will look at this one here and say, oh, I'm multiplying by 2 each time. Sometimes it's not as easy to see. So to find your R, you can always take one term divided by the previous term. So over here, we could take 36 divided by 108. Simplify that down. If that ends up being the same thing as 12 divided by 36, that means this is geometric. So when we do that for this problem here, take 36 over 108, we get 1/3, and 12 over 36 is 1/3. So our ratio is 1/3. So we're multiplying by 1/3 each time. So to be able to get to the next term, all we have to do is just multiply by 1/3. So we have 12, multiply that by 1/3, and we get 4. 4 times 1/3, and we get 4/3. 4/3 times 1/3 is 4/9. But we're also asked to find the 10th term. So that's where we want to use our general formula. We could go ahead, now that we've already listed out to 4 over 9, which is our 6th term, we could just continue to do that till we got to our 10th term. But if I had asked you to find your 100th term, that would not be nice to do. So we're going to plug in our first term. We're going to plug in our ratio, which is 1/3. And then we're looking for the 10th term. So we're going to plug in 10 for n. By the way, this one right here with n's in it is your general formula. We're looking for the 10th term, so we plug in 10. We can type that into your calculator. 108, put 1/3 in parentheses, raised to the 9th power, and we get 4 over 729. And you'll probably have to change your answer from your calculator into a fraction. So go ahead and quickly do the next one. You'll notice your ratio is 2, so you're multiplying by 2. 12 times 2 is 24. 24 times 2 is 48. 48 times 2 is 96. Then we want to go ahead and find the 10th term. So we'll go our first term of 3 times our ratio of 2 raised to the n minus 1. Looking for the 10th term, plug in 10. Plug that in our calculator. We get 1,536. Now, there's a couple ways to do this one here. You're looking for the seventh term. You're given the third term and you're given your ratio. Well, one way is you could just keep multiplying by 2 because that's your ratio. So 96 times 2. Then take that answer times 2 to get to the next term. And that's your 5th term. Notice how I have a sub 5 here for the 5th term. To the 6th term, you get 384 times 2, and we get 768. 7th term would then be that 7068 times 2, and we get 1536. That's one way to do it. However, if you were looking for your 28th term when you were given this information, that would be kind of a pain to do. So a second way you could do it is you could go ahead and say, okay, if I'm looking for that seventh term, but I treated a sub 1 as the first term, that's 2 less. That means I'd really then be looking for my fifth term. There we go. So then I could use my formula just like I was doing on the previous page here, right here. Put in my first term, put in my ratio, my first term really being that third term, my ratio, and plugging in 5 for my fifth term. So that's a second way it could be done. Most of these problems can be done in multiple ways. Now, just like with the arithmetic sequences, we had arithmetic means. With geometric sequences, we can also have geometric means. For the most part, that means we have this number. We're looking for 3 geometric means, so there's going to be 3 numbers in between, and that's our last number. So in other words, we have our geometric sequence written out in green. So we need to find the 3 missing numbers, so it ends up being a geometric sequence. Well, there's a couple ways to do it. One way to do it is you could say, well, that's my first term, and we don't know what r is, but we do know that for our fifth position, that would be n, our term is 49.92. So we could plug in 49.92 over here for our last term. Our first term, r raised to the fifth minus 1, which is 4. N is 5 because that 49.92 is in the fifth position. So then all we have to do is solve that. We'd want to go ahead and divide both sides by the 3.14. Then we'd want to take the fourth root. Remember, when you take the fourth root, you get an even, or an even root is plus and minus. So we need to consider the situation where r is a positive 2, and then we'll have to consider the situation where r is a negative 2. So we'll take that first term, which was 312. We're going to double that. Then we're going to have to double the second term, which we just had, of a 624. Then we're going to have to multiply by a ratio by 2 of getting this. And then you notice those are your geometric means. If you take this last one and multiply it by 2, it does give you this right here. So that's how you can double check your answer. Then you also want to go ahead and find your other geometric means with r being negative 2. So you take your 312 times negative 2 and you get negative 6.24. Multiply by negative 2 gives you positive, and then multiply by negative 2. And so that's how you get your geometric mean.